Hello and welcome to the Math Critique, where I take topics you might be struggling with and I show you that you can do it because you already have. Today's topic is going to be focusing on what is a radian. So let's dive in. So to start off, I'm going to have this is going to be the full video, and then we're going to have a TLDR linked below. So to start off, I want to talk a little bit about what measurements are. Okay, now with angles, we usually talk about angles being in degrees. There's 360 degrees in a full circle. 180 degrees would be a straight line. But we talk about angle measures in degrees, and you've been doing it for so long, you're so used to it, it makes sense. But the problem is it doesn't. Okay, when we're talking about length, if we're talking about units of length, we could be talking about feet or inches or yards or meters, kilometers, miles. We could be talking about all these different ways to measure length, but length is just the distance from point A to point B. That's really all length is. That makes sense. If we could do the same thing with area. There's a bunch of different ways we can define area, but really it's the space within a two-dimensional plane. It's how many, one by one boxes are going to fit into a space. So we can talk about it in a bunch of different ways, but really, when we talk about uh, area, we're talking about filling in a space with one by one boxes. And the one by one, those could be any units. Those could be inches or feet or yards or meters. We can do the same thing with a volume, and we could be talking about length, width, and height. So we'd be talking about cubic inches or inches cubed, if however you want to say that. Cubic meters, you could be cubic centimeters, you could have a lot of these different things, and then we get into different types of volume. We could have cups and milliliters and gallons and all these other units that all talk about volume. You can do the same thing with weight. We have pounds and kilograms and all of these different weights. All the weights are just talking about, depending on how you're looking at it, it's mass or it's the effect of gravity on the object and how much gravity is pulling down on the object. So there's different ways to describe it. But all of these have really good definitions. What's degree? That's where things get a little weird. Okay, so if I have an angle measure, uh, what are we exactly measuring? We're not measuring the distance between the two lines. That doesn't make any sense because closer to the vertex is going to be a shorter distance than further from the vertex. We're not talking about area because these could be two lines that area could go on infinitely. So there could be an infinite area, or it could be an incredibly small area. We could have a 30-degree angle in a very small triangle or a very large triangle, so area doesn't really describe it. There actually is not a really good definition of degrees, of what degrees are measuring. There's a couple that you can kind of work with. You can talk about the percent of a circle that's being measured, and that would be one way to do it. Not exactly the best way because angles, degrees are separated into 360 in a full circle. Well, 360, the question then comes in, why 360? And I was asking my daughter that same question just a night or two ago, and she said that one of the best reasons I've heard, because somebody liked the number. And that's pretty much it. 300, they use 360 degrees because it divides evenly by a whole bunch of different numbers. You can take 360 divided by 2, 3, 4, 5, 6. Can't divide by 7, but you can divide by 8, 9, 10, 12, and it goes on and on. It's a number that you can divide a whole lot of things by. So we can take a circle and we can divide it into, if we take a circle and divide it into quarters, then each of those quarters is going to be 360 divided by 4, 90 degrees. So there's a whole bunch of reasons why we use 360. But still, we don't have a good reason as to why, what degrees are actually measuring. So, radians are what's going to take care of that. Now, one way to think about radians is radians are a different type of measuring system, kind of like when we can measure in feet or we can measure in meters. We can convert between the two. They're measuring kind of the same sort of thing. In the case of feet and meters, they are measuring the same thing. It's a different measuring system. We can convert between the two, and that's fine. With degrees and radians, and there is actually, I've heard, I haven't worked in it, but you can also use something, I believe it's called gradians, which is another system altogether, which just isn't used very much. Uh, but we do have degrees and radians, and we can convert between the two, and we can see how to convert and how all of that works out. So, what we're going to do is we're going to dive in. We're going to see first what is a radian and how do we convert between the two, because one actually feeds right into the other because math builds on itself. Okay, so it's actually going to be pretty easy to describe angle measures using radians. Okay, so to be able to do that, uh, you don't. You don't actually describe the angle measure. Okay, it sounds counterintuitive, but it actually works out pretty nice. Okay, so what I'm going to do is first off, uh, an angle is what you get when two lines intersect. So here's my first line, and here's my second line. Okay, so now I have two lines that are intersecting, and we're going to look at this region here to describe the size of the angle between them. Okay, so to do that, I'm going to put this on a coordinate plane. Okay, so that means this first line, the first line that was on the screen, this horizontal line here, uh, that is going to be my x-axis, so I got to put in a y-axis, so I have a line going vertically. And what I'm going to do is I'm going to put a circle around that. Okay, now notice everything is focused here at the center of this circle. I have the angle, this is my original angle. I have the origin where the two axes meet is the center of the circle. Okay. Now the nice thing about this is going to be called a unit circle. Okay, so what that means is it's a circle that where the radius, the distance from the center to the side, is 1 unit. So that's why it's called a unit circle. It's 1 unit from the center to the side. Okay, and then what I can do is instead of figuring out this space here in saying degrees, not really having a good definition of what degrees are, I'm all I'm going to do is I'm going to find the arc length. I'm going to find this length around this outside of the circle. You might have heard of it described as if you were an ant walking around the outside of the circle, how far did you go? Okay, so that's what we're going to use to describe the size of the angle. So to do that, we got to start off by figuring out what is the circumference, the formula for the circumference of a circle. Well, the formula for the circumference of a circle is 2 pi r. Everyone always says pi r squared. That's area. Circumference is 2 pi r. 2 times pi times the radius. Okay, now we just said that because this is a unit circle, that means that the radius is 1. So if the radius is 1, I can just plug 1 in for r, and the circumference of the circle, if I walk all the way around the outside of the circle, all around, that ends up being 2 pi units. Well, if you think about what radians are, one full rotation around the outside of the circle is 2 pi radians. That's because that's one full circumference of the circle. So if you go all the way around the outside of the circle, that's the circumference. That's also the radians. Okay, so how does this help us to figure out how to find radians? That's an excellent question. So what we just determined is that all the way around the circle is 2 pi radians, because that's the circumference of the circle, 2 pi, circumference of a unit circle. Okay, so we know that the full circumference of the circle is 2 pi radians, which is the same as 360 degrees. Okay, so what I'm going to do, just to make this easier to see, is I'm going to get rid of these units. I'm going to get rid of where it says radians. I'm going to get rid of the degree symbol. I'm going to keep saying it so that it's easier to follow. Okay? So what this tells me is that 2 pi is the same as 360 degrees. So 2 pi radians is the same as 360 degrees. Which means if I divide both sides by 2, that means that pi radians is the same as 180 degrees. Okay, now I did that just because I wanted to get pi by itself. I wanted to get pi to be kind of the smallest unit. Okay, and the reason I did that is because that's going to help us out here when we do conversion. Okay, now before I move on, though, I do want to point this out. So 2 pi is the same as 360 degrees. That's all the way around the circle is 2 pi radians, and it's the same as 360 degrees. Halfway around the circle is 180 degrees. That's pi radians. So we just used math to show that this is true. Okay? You can keep going with this and you can say, oh, well, just half of that, that's a 90-degree angle. That's if I took that 180 and divided it by 2, I'd get 90. Pi divided by 2, we usually just leave it as pi over 2. And that's a 90-degree angle is pi over 2. So you can keep dividing this and you keep getting these angles, okay? But we don't always have nice angles that are easy to do this with. So it's really, we prefer having something we can just multiply by. So let's do that. Okay, so let's say I have 60 degrees, okay? What I'm going to do to be able to change the 60 degrees to radians is I'm going to multiply by pi over 180. Now, big question always comes in here, why do we multiply by pi over 180? Well, think of this like a fraction. If I have the same thing on top and the same thing on bottom, that means when I multiply, I'm multiplying by 1. If this was 4 over 4, that'd be 4 over 4 is 1, so you're multiplying by 1. This is how we convert fractions. We change to common denominator to get common denominators, and you multiply top and bottom by the same thing. It doesn't change the value. So here we're going to multiply by pi radians over 180 degrees because those are the same. And when I multiply that, I get 60 divided by 180 is 1 over 3. And then the pi stays right where it is. So this is pi over 3. And you can check the math on that if you need. So 60 divided by 180 is 60. You cancel everything out. You get 60 is 1. 60 cancels out and you get 1. 180 cancels out. You get 3. However you do that in your class. So you can go through and you can reduce the fractions just by multiplying them. So if you want to go from degrees to radians, multiply by pi over 180. Let's say I want to go the other direction. Okay, so now let's say I have 3 pi over 4. Well, if I want to change this to from radians to degrees, it's actually a lot simpler than it sounds because I just take that fraction, I flip it over. Okay, the 3 pi over 4 times 180, you can cancel these out however you want. Start off, look, there's a pi on top, pi on bottom, they're going to cancel. So you just have 3/4 times 180. Okay, so you can start off by doing that. Make the math easy on you. Once you go through and multiply that out, you find out that the degree is 135 degrees, the degree measure. So that angle is 135 degrees. 3 pi over 4 is the same as 135. The way, this may sound really too simplistic, but it's really the way I do it. The way I remember which value goes on top and which value goes on bottom is I remember all of my radians, I always have a pi in the top. So when I want to convert 2 radians, I need to multiply by the fraction with the pi on top. That's the only way I'm going to get my pi on top. So the 180 would have to be on bottom. And then you just flip that over to get go from radians to degrees.